Hi, I am Ranveer Chandra, and welcome to the first panel session of the Research for Industry track, in which we will discuss the future of telco and space. At Microsoft, we believe that 5G will create tremendous value for the enterprise, the same way 4G did for the consumer. Farmers will get better connectivity in the farms. The supply chain fleet and warehouses will have continuous connectivity, high-speed connectivity to the cloud. The manufacturing plants can create accurate digital twins of factories. And all of this will be possible with the intersection of the physical and virtual worlds powered by 5G, enabled by 5G edge zones, cognitive services, IoT, Teams, mixed reality, and all of that running on top of 5G. At Microsoft, we are working on both the applications, which you will hear about in the rest of the panels today, and the 5G technology itself. Through our work on Azure for Operators, we have a vision of a unified platform for 5G across the edge and the cloud, where you can run network functions anywhere, such as vRANs in the edge, core services in the cloud, and OTT services in the edge and the cloud. We are partnering very closely with the operators to provide the core infrastructure and the service delivery platforms. The internet transit itself, we are working on that. That will be powered by a low latency, very well managed Azure WAN link. And the entire system, from the edge to the cloud to the RAN, everything will be programmable. And it will be capable of running the next generation of applications and services. Towards this vision, we are working ourselves and with collaborators on different layers of the network stack. From massive MIMO systems to fully programmable RANs and RF, we are working towards a vision of 6G. This is networks that will be even faster, that will be even lower latency, that's going to be super resilient, and which will be pervasive. Of course, to make it pervasive, the vision that we have, it will have to reach remote parts of the world. And one way that is possible is using space communications. At Microsoft, we started a new program called Azure Space. Through this program, we are working on technologies to connect the world, such as Azure Orbital, which you heard about in Ravi's talk. We are building technologies to generate insights on Earth observation data, such as the SpaceEye technology that Ravi talked about that can see through the clouds in satellite imagery. Additionally, we are building tools to help the space community innovate faster. Think of simulators, think of tools that you can use for your research, for your innovation. And our longer term vision is to put Azure in space. Actually, it is not that much into the future, as you can see through some of our announcements over the last year. We've announced ways to automate satellite imagery processing. And in addition to that, we have put compute on the edge in space. Very recently, we partnered with HP Enterprise to put compute on the edge, that is on a computer that is in the ISS, the International Space Station. And in addition to that, we are continuing to do scientific research and publish papers on Earth observation, on spectrum, on new satellite communication architecture, such as a distributed ground station that was published in this year's SIGCOMM. In this work, we are augmenting existing ground station infrastructure with low-cost ground stations that are receive-only and which are much more inexpensive. And you can deploy many of them that can complement the more expensive, more stable existing ground station infrastructure to significantly reduce the time of transfer of data from space to the ground to Azure. Please do check out our research website to learn more about the research we are doing. In fact, over the last year, we also partnered with the NSF on the RINGS program, which is envisioning the future of wireless systems, the hard problems that need to be addressed. Thank you to many of you for applying to the RINGS program, and we are very excited to partner with you on solving some of these hard problems. So with that, welcome again to the first panel session of the industry track of the Research Summit, in which you will hear leaders in telco and the space industry on how data, cloud, AI, All of these technologies are transforming these industries, what the future holds, and some of the hardest problems that need to be solved to achieve the full potential of these industries. Thank you.
Good morning, good afternoon, good evening, everyone. My name is Dina Papagiannaki, and I'm the Vice President of Engineering of the Mobile Packet Core team inside Azure for Operators. And I would like to welcome you to the Future of 5G panel. It is remarkable to consider that it has been nearly 40 years since the introduction of the first mobile phone. The Motorola Dynatac weighed almost 2 pounds, cost the equivalent of $10,000 today, and lasted 30 minutes on a single battery charge. The mobile telecommunications industry has come a long way in the past 40 years. It started with a goal to connect humans while they were on the move. It evolved to text services, connecting mobiles to the internet, and we are now at the cusp of connecting billions of devices through low-latency, high-throughput 5G services. The 5G launch is further accompanied by a rather significant transformation of the underlying networking infrastructure, creating unique opportunities to bring the flexibility, scale, and cost efficiencies of the cloud to the telecommunications industry. The question then becomes, what's next? To do that, let me welcome our 3 invited panelists that are joining us today from different parts of the United States. I'll start first with Martin Casado. Welcome, Martin. Martin is a general partner at the venture capital firm Andreessen Horowitz, where he focuses on enterprise investing. He was previously the co-founder and chief technology officer at Nicira, that was acquired by VMware in 2012. He is attributed with one of the greatest networking innovations in the past decade, software-defined networking, work that he started while he was at Stanford. So welcome, Martin, and thank you for joining us today. Moving on to Andre Fuetsch is an Executive Vice President and Chief Technology Officer at AT&T. He oversees the global mobile and fixed networking technology direction for AT&T, which includes the design of the company's 5G infrastructure, AT&T's software-defined networking initiative, protecting and monetizing AT&T's intellectual property portfolio, and the network's software automation platforms. His responsibilities include network architecture, standards, planning, development, testing, and the certification of infrastructure and device technologies. Welcome, Andre. Last but not least, let me welcome Martin Lund. He is the Corporate Vice President of Azure for Operators. He is responsible for the Azure for Operators engineering, product, sales, and services teams. Martin was the CEO of Metaswitch Networks that Microsoft acquired in 2020. Prior to Metaswitch, he served as Senior Vice President at Cadence Design Systems and held a 12-year tenure at Broadcom, where he led its networking switching divisions. So welcome, Martin. With no further ado, I would love to move to the questions, as we try to explore what are the remaining challenges and opportunities for the future of 5G. And the first question I have is the following. It has taken us a while to define, develop, and launch 5G. What do you think will be the killer app for this new generation of mobile technology? And how do you think it's going to affect your own personal lives and society as a whole? Martin, would you like to get started?
Yeah, sure. So, listen, I don't want to sound too dramatic, but I actually think 5G can play a pretty important part in destabilizing the cloud as we know it. And to kind of run up to that very quickly, we've had 126 software companies IPO in the last 6 years, 126. And the majority of those are these cloud-native companies. And we really haven't understood the economics of the cloud, because, in the past, cloud was not part of a SaaS company or cloud-native company. But if you look at these 126 companies, a major portion of their COGS is actually cloud. It's a line item. And it's for a good reason, but this really impacts their share price. It really impacts what they build, just because they're beholden to this traditional cloud. And there hasn't been a lot of technology that has the performance that you need to push these workloads to the edge. I think 5G will play a very important part of allowing applications to decouple from the traditional cloud model. And I think that there's enough economic pressure. There's probably $1 trillion being depressed as a result of this. And so I think that you've got an economic pressure that will push out. I think 5G is going to provide a very important conduit of that. And I think that we're going to actually look at cloud very, very differently. And that impacts my life because I'm an investor, and there's a $3 trillion IT market that's going to be blown up as a result.
Thank you, Martin. Andre, any thoughts?
Yeah, I agree with Martin. I think there's a lot of really interesting things that we're going to see that 5G is going to enable. And I think certainly this sort of centralized compute to distributed compute, this sort of pendulum shift, 5G could be a pretty good enabler of that. I'll probably answer the question a little bit differently. I think down the road, and it's going to be a while, but probably what replaces this as the killer app will probably be some form of a wearable, like augmented reality glasses, or maybe even something you would wear on your wrist, a little bit bigger than your watch. And I think in a way that has the potential to really displace the smartphone as we know it. Now, is it going to happen in the next year or two? Probably not. But maybe towards the end of the decade, I think a lot of these technologies, and this is an area I spend quite a bit of time focusing on, and actually I'm on the board of a AR company. I really see how fast that technology is evolving. And just as you said, Dina, where we started at 40 years ago with the form factor and the power consumption and the cost, all of those trajectories are changing very, very quickly. And I think we could expect to see an entirely new form factor in the way we connect in the world. And 5G is going to be how we connect with it.
Wonderful. Martin?
Yeah, I think it's fascinating perspective, and I do agree with a lot of it. I do think, however, instead of saying it becomes dispersion of the cloud into the edge, I think there's a massive amount of new use cases and compute requirements that will be enabled by 5G. From a killer app perspective, all the legacy Gs have been really about connecting and enabling communication between humans. And 5G is really the first major effort to connect things, devices. And people are saying maybe 50 billion connected devices. And what does that mean? Well, that's interesting. What does that mean? Well, 5G can be helpful in tackling climate change. It takes power to run these networks, but if you can enable smart cities to reduce power, be much more effective at controlling the resources that are being spent, it can be helpful in that. But then I think the killer app is probably, there's not going to be one, there's going to be many, because it's not just about humans anymore, it's about industries that are going to transform. Another way to think of it, I look at 5G as sort of, it's almost like the role Ethernet had in terms of being a unifying communications protocol that then allowed many things to build on that. You can say early days Ethernet was to connect computers and desktops. Okay, then suddenly it actually instead of ATM became a technology that was used in telecom network as well, because new capabilities and standards were supported. It was used and modified to adapt what the cloud is now using. All clouds are running on Ethernet communication. It's found its way into automotive. But the one thing about Ethernet is that it's not very helpful in a world where you can't pull a wire if you're running a robot, or you can't carry a cable as well. But I do think the similarities of these requirements from all sorts of different industries, whether it's high bandwidth communication, low bandwidth communication, or if it's low latency communication to control robots, all those use cases will be built on top of the 5G standard and subsequent releases. So many killer apps.
Wonderful. So it's not one, it is many, and it's not only targeted to people, but to the industry and society as a whole. I love that we touched all these points. We mentioned a little bit edge computing, and my second question has to do about edge. So we have been talking about edge computing for more than a decade now. What is so special about 5G and the edge? Andre, maybe you can start.
Yeah, look, I think there's there's tremendous hype out there about the edge and 5G, and we're still sort of waiting for something to happen there. But I can tell you there's a lot of little things going on that are really interesting, and I'll pick one use case, and that's autonomous cars. So if you look at some of the cars that are out there, the most advanced ones that actually can drive completely on their own, they're really sophisticated. They're really a sophisticated sensing machine. They have upwards of 12 plus cameras, active radar, LiDAR systems, ultrasound systems all around them. And when you look at the amount of data that's flowing through that car to process all of that information and to keep that car going down the road to get you safely to your destination, that car is generating something on the order of about 3 terabytes of data an hour. Now, to process all of that, you effectively have a little mini data center in the trunk of the car. But as we all know, the car, at least the cars of today, are one of the worst utilized assets we own. At least in the United States, the average utilization of a vehicle is about 4% of its operating life, meaning 96% of the time that car is sitting idle, probably in your garage or in a parking spot. So the opportunity here is, how could you take some of those resources to do all that processing and take it out of the car, but where would you put it? Now, some of it you certainly could put in a data center that's 500, 1,000 miles away, where latency probably isn't a big deal. However, there are some functions that are probably more latency sensitive that you could put somewhere in between, and that would be the edge. And so now you have this opportunity where you can now put some resources at the edge that now could be shared, not just with one car, but multiple cars. And that's where 5G comes in to make all of that happen. So I think that's one example that we can see actually in the near future where edge computing and 5G can really help a use case that's evolving like autonomous driving.
Wonderful example. Martin?
Yeah, I think, and maybe this is relevant for Microsoft Research discussions, to go back and say the edge compute and 5G has a lot to do with the laws of physics, which is always a good guiding post and a driver. So what does that mean? I believe a lot of these communication systems and industry solutions will require certain things, basic things. There's latency. Andre talked about latency. And latency is one of those things that's governed by speed of light. You actually can't fake it. There's a distance and that's it. So if you have to have sensor and actuator control loops, like in a car, that is in the millisecond domain, you are limited for how far away your compute resource can be. So that's one thing. The other one is also in the car analogy is backhaul, which is how much terabyte of data can you send back into the cloud. And yes, if you live next to a data center, an Azure data center, maybe you have a really low latency and a nice fat backhaul pipe. But in most places, backhaul is still expensive, and data generation goes up when you have more and more sensors. So backhaul, I believe, will always be a constrained resource. And you go faster, it gets harder, Shannon's law kind of a deal, right? Then the last piece is basic locality, which is it's data sovereignty. There will be applications where we say, I will not have this data leave my zip code or my building. And it can be for privacy reasons. If I do if I use facial recognition, I don't want my pictures uploaded to the cloud, but I maybe want to do it. Or it can be the Coca-Cola trade secret that cannot leave Coca-Cola's premise, but they still need to be able to use it to manage the manufacturing process. Things like that, privacy, data sovereignty, are also a form of laws of physics. You can't be in two places at the same time. So I believe that's the drive for it. More and more data generated at the edge, more and more processing have to be closer to it. And you have these additional things that backhaul is expensive and some data can't leave the premise.
Martin, any thoughts from you?
Yeah, so listen, I'm happy to be with two futurists that understand where the future is going, and that's really exciting. But for me, I'm like an old school IT guy, and the biggest disruption is just a $3 trillion cloud market that's going to be upended. And I actually think 5G is going to play a big part of that. I really think that it democratizes connectivity. And when you talk about edge, everybody has a different definition of edge. It's the phone, it's whatever, it's some manufacturing device. But really, when it comes to IT, the edge is where you can stick servers for your CDN. And if you look at what's actually pulling workloads from the cloud, it's these CDNs focusing on special purpose workloads, maybe it's just caching, maybe it's an OLAP database, maybe it's an OLTP database. But in order to do that, you have to have wires and everything else, and you just haven't been able to solve the distribution of I want an edge workload that does kind of core IT stuff. I think with 5G you can. It just allows, listen, if I want to build kind of a global CDN that kind of pulls workloads away from the clouds and makes them more available, finally we have a non-wired way to do that. And so again, there's a lot of new applications that are going to happen, and they're super exciting, but $3 trillion IT budget will also be disrupted, and these are traditional workloads, and that's also super exciting.
I love the notion, of 5G democratizing access to compute, if I were to generalize it a little bit more broadly. So I think it's an interesting concept of the type of transformation that we are bringing here. My next question is actually, relatively close to what you have been discussing so far. So let's see how we take that. The cloud has brought tremendous economies of scale to general and specialized purpose compute. What role will the cloud play in 5G and the telecommunications industry? How do we see this type of relationship evolving over the next few years? Let's see, in terms of ordering, I think now it's Martin's turn to go first.
Yeah, maybe a little bit biased, but I do believe that the cloud has a huge and critical important role in unleashing the power of 5G. Billions and billions of devices. There are 6-7 billion mobile subscribers today, but more than 10 million subscriptions for a plan of some kind. So people carry multiple devices. But the whole aspect, that's so rough numbers, 10 billion. But there's going to be, in a short few years, going to be tens of billions of more devices that will be connected to the network, which is not humans. It will be cars, it will be thermostats, it's going to be a bunch of stuff. In order to manage those large sets of sensors and solutions out there, you need to have a hyperscale approach to it. You can't do it at the edge and do it one by one and one guy sit on a spreadsheet. It has to be done with a hyperscale mindset and think of it as the single pane of glass is likely going to be in the cloud. And you're going to do a lot of edge computation, but in order to really manage security policies, making software upgrades for these end devices, doing all the hard work of actually keeping this functional, up to date, up to speed, have to be done with a hyperscaler approach, which have revolutionized the IT industry, because you now do things at scale. That if you don't do it at scale, it doesn't make economic sense to even begin.
That's interesting, Martin. Martin, any thoughts in response?
Yeah, listen, I think the cloud is sucking the life out of the entire industry, and you can just look at the numbers. It's just unbelievable, the cost of using the cloud. I mean, it's billions of dollars for these large public companies. And when you're talking about scales, these are like at-scale companies. Like these are deca-billion-dollar companies that have predictable workloads and whatever. What they don't have, though, and what's really hard to get is points of presence and connectivity. And so I think 5G has a huge role to play in destabilizing the cloud as we know it. The concepts of the cloud are totally valid. But the idea that they're wrapped up in a few companies and contribute a ton to the cogs of like the entire SaaS industry isn't. And so I'm super excited about 5Gs and its interaction with the cloud, particularly for this reason.
Andre?
Yeah, let me just kind of add to that because I think Martine is really exposing something that's a huge opportunity here. 5G is really the bridge to choice for developers because we talk about the cloud, but I think the power is in the developer community and how they're using this. And if you think about the frustration there, the frustration is really happens in the wallet, right? There's a lot of control there with very few. And developers, traditionally have only really worried about compute and storage. They kind of, the networking was always sort of this afterthought. It is what it is. But now that we have this new bridge that gives you optionality of wherever you want to run your particular application or break it up or distribute it, well, how are you going to move that around? How are you going to run that in the most cost-effective way or whatever your objective is? I think that's where 5G can really help. So I'm banking on and hoping the developer communities can really embrace the network finally, because it's always been sort of this orphan stepchild, that didn't get all the attention, right, as compute and storage have over the last several decades. And now is really the time to take advantage of this and for the developers to take some control back and they run it where it's most cost effective or whatever's going to make that experience they're trying to achieve even better.
I can add to that. I used to say that there are three things in life that matters: compute, storage, and networking. Now I have changed my view on it. Now it's networking and developers that are the two things in life that matters. But that's so I'm fully on board with your perspective, Andre.
That's great. Last question, that I had, and then, I would love to see, if you have any other thoughts. So in the past few years, and here we are going a little bit farther out, in the past few years we have seen a number of companies launching satellites around the Earth at a rate that was never seen before. We have managed to essentially drop the cost of launching a satellite to something that can happen on a weekly basis these days, no? So the question here is, will we even need a 6G? And what do you think the telcos will look like in 10 years' time if they exist? Let's get started with Martine.
Okay, listen, I really love this question because it kind of aligns with an aha that I've had in the last few years, which is, so I actually sit on the board of a satellite company that does backhaul, and it's a geosynchronous satellite company. And when I was researching whether to invest in this company, I wanted to understand, what's the size of the market? Will LEO, constellations destabilize geosynchronous? What about, what if people come up with a great microwave technology? Whatever. And the conclusion after doing all of this work is that probably the largest market in all of technology is networking. People want to communicate. And they're all going to exist. There are points in the design space for all of them. Geosynchronous is phenomenal for high throughput workloads. Maybe higher latency, but higher throughput. LEO is great for a certain point in the design space. We're talking about hundreds of billions of dollars of market. And so, listen, I think each one of these is going to be needed in the future. I think we're going to need telcos as service providers to run them. I think they're going to evolve independently and they're going to work together. And if we create a new way of communicating, that's not going to be a zero-sum game. It's going to be an and on top of it. And so I think, I think networking is probably the most relevant, largest market that we can work at.
Wonderful, Andre.
Yeah, let me add to that because it's a pretty exciting space. And look, I don't believe there is, one silver bullet mode of access. I think it's, connectivity to be connected all the time, anytime, anywhere is really going to require a multimodal view in terms of access. And I'm excited to see all this competition that's, brewing out there in space, no matter what orbital plane they're operating at. But I will say this, obviously, as an engineer here at a large telecommunications company, we've spent a lot of time running the numbers on this. And, so far, the economics still skew really, really strongly in terrestrial networks. And a lot of it is, Martin brought it up earlier, it's just the laws of physics, right? To carry packets, depending on, where you're orbiting up and how fast these things are whizzing around, these aren't easy, trivial things to do. The other thing too, with respect to satellites is, we all gotten kind of used to these very small, slim form factors, and you look at the technology it takes with the antenna front ends, and there's a lot of work that has to happen before you can expect to have a small little device, connected. Yes. Things are improving, technology is always getting better, but at the end of the day, I still think for most of our needs, the terrestrial network, and especially fiber-based networks, because the economics also suggest the faster you can get the bits off the air and into glass, the better the economics. And so that's a lot of what goes into the calculus here. But it's not to say there aren't great use cases for satellites to keep us connected no matter where we are on this very small globe that seems to be getting smaller and smaller by the day.
Thank you, Andre. Martin?
Yeah, I agree with that. The interesting thing is when it comes to communication, there's going to be an ever-increasing appetite for more bandwidth and more communication solutions. I think the super interesting part of the satellite coverage and the whole motion in that, is really help closing the digital divide. It is being able to deliver broadband communication solutions and other communication solutions to areas that simply can't, that don't have to, can't afford to pull the fiber out to the village and whatnot. I mean, there are hundreds of millions of people that have insufficient access today, and I think that's super interesting. There's other things, which is it provides a great backup if your main link goes down, and you can do things, you're not completely disconnected. So I think it's super interesting, all these access technologies. But at the end of the day, and it's a truism, when it comes to networking, there's one currency that sums it all up, and that's picojoule per bit. So that's the notion to look at that. When you can compare everything and you can say, well, it takes me 20 picojoules per bit if I go over a satellite, then you know that it costs N amount more than if it's 1 picojoule over a fiber. So there's another, great analogy there. Shannon's law is a great one to go and look up on when we think about networking in various mediums. But closing the digital divide, opening up new use cases for always connectivity in rural areas and even in cities, I think is super cool. It's going to be, however big you think 5G and the edge compute is going to be, it's going to be bigger than that. That's my prediction.
Wonderful. So we are near the end of our panel. I wanted to thank each one of you very much for taking the time to be part of here. I love the fact, that we have very different perspectives from an operator, from Azure for operators, and then, from the investing aspect of the business as well, which I think is what Martin is bringing to this discussion. I just wanted to save those few last minutes to hear maybe some parting thoughts, that each one of you has based on the discussion that we have had today. Martin, do you want to go first?
5G is going through sort of the classic hype cycle, and we're in all technologies are going to get hyped up, and it's going to be great. It's going to solve everything, and then we go sort of into, well, it really doesn't. It hasn't done much yet, and then what? I do believe that 5G as a universal access technology combined with its computing capability will be a tremendous enabler for a bunch of innovation, and that's what really gets me excited. I can see the amount of stuff that we can now do that we couldn't do before. It was not practical, it's not reasonable. And there's a whole generation of young engineers and entrepreneurs that will take advantage of this in ways we can't even predict today.
Wonderful. Andre?
Yeah, I'll just add, we all know what 4G brought. It brought the gig economy, right? Take your favorite pick, whether it's, how you order up a car or order up your lunch, or, book a hotel room or an airplane ticket. I guess we're not flying that much these days. But, 5G, I think, although we don't know what all the new killer apps will be, there are a lot of guesses out there. We shared a few. There's something really special about 5G that a lot of people and engineers have worked on through the standards. And in comparison to 4G, as an example, the 4G network has the ability to control in a given square mile area tens of thousands of simultaneous device connections. The clever architects of 5G went and took that tens of thousands and actually turned it into millions. And, Martin brought this up earlier. 4G was really about connecting humans. He mentioned 5G is also all about connecting machines and all the things in our lives. And so 5G is really going to create this control layer to do this in a very consistent, scalable, secure way. And it's really that control layer that I think has a tremendous amount of potential to help us manage the morass of connected devices in our lives, and to make sure that, we're doing this, securely. We're doing this in a way that we feel we're, keeping our privacy, and we're doing this in a way that really is adding value to our lives. And there are very few technologies out there that can do this at that kind of scale. So I'm hoping all these developers and that are out there, when they start looking at what they can do with 5G, they can start tapping into that capability.
Thank you, Andre. Martin?
Yeah, honestly, I don't have too much to add, so I'm just going to restate what both Martin and Andre, I think, said very well, which is, listen, I think in life it's great to have an abundance mindset, which is rather than things being zero-sum or whatever, it's like, there's room for everything. And that just seems to be the case with networking in general. Every time that we add a new type of network, people find ways to use it. And I think probably the biggest step of that is going to be 5G. I mean, it's just very, very clear that it makes practical things that people have wanted to do. It hasn't been impractical before. And so it's just really exciting to see this come out and to see kind of the Cambrian explosion in new use cases that's going to be enabled as a result. And that's that.
Sounds good. Lots of things to think about, with respect to the future. I'm really excited to see, how we manage to use this type of new technology to democratize access for everyone and everything, which is, I think, the conclusion of this panel. I wanted to thank each one of you very much for being here today and helping us understand a couple of things, around this particular technological innovation, which I think is very important. The other thing that I wanted to say, closing this panel out, is that for those of you watching, the next panel is actually on satellites. So, hopefully, the past 10 minutes, give you a little bit of a sneak peek look into what the discussions over there may be. So with that, thank you everyone, and goodbye.
Welcome to the session on space in the Research for Industry track at the Microsoft Research Summit. Over the last few years, we have seen a lot of excitement in the space industry for a variety of applications, from Earth observation, seeing Earth from space, to communication from space. You look at how do you connect the rest of the world using these low Earth orbit satellites, to space exploration, looking what's outside the Earth at Mars and other at the universe, and space travel. We are continuing to push the boundaries of technology. And today, to discuss all these exciting developments, we have the space lead at Microsoft, who's also a senior director here, Steve Kate. So Steve's been at Microsoft for about a year. He had a career in the government and held a range of positions in national security, where Steve helped build and launch satellites. Then he went to Capitol Hill to advise members of Congress. And in his last job, Steve was Deputy Assistant Secretary of Defense for Space Policy at the Pentagon, where he helped stand up the Space Force. Very interesting career, Steve. Thank you for joining us. Could you share your insights around the recent excitement in the space industry and what brought you to Microsoft?
Thank you, Ranveer. It is great to be here with you and with the research community today. So there's this massive transformation that's going on in space right now. In fact, it's really at an inflection point. If we look at, there's a range of numbers and statistics to judge that by. One would be the investment going on in space right now. $7.6 billion of commercial investment in space last year. That's one of the big changes that's happening, is it's not just governments and superpowers, which that was the history of this domain. The commercial industry is getting extremely involved. They funded over 100 companies last year, startup companies. Now, in addition to the funding, there's the technology. Thousands of satellites are being launched. Last year alone, over 1,200 small satellites launched. This is about 40% of the satellites that were launched over the past 10 years. So we're hitting this tremendous growth curve, particularly in low Earth orbit. So what drew me to Microsoft at this time is the opportunity to do something important here in the private sector and really enable the industry.
Yeah, and at Microsoft, I'm really proud of all the different things we are doing, and especially since we launched Azure for Space. Could you tell our audience a little bit more about what is Microsoft doing in this space?
Sure, absolutely. So as you mentioned, Microsoft launched Azure Space. We've been working on it about 2 years, but we launched it publicly last year. And it's all about bringing the cloud and space together. And this is because we recognize how important space is to our customers, as well as the massive amounts of data that's being collected from space. So what we're working on is new connectivity solutions, new analytic solutions, modeling and simulation, and we're doing it through a partnership ecosystem. So Microsoft isn't actually building and launching our own satellites. We're partnering with others who do. So a few examples of that is SpaceX and their Starlink constellation. I had mentioned these thousands of satellites that are being launched. SpaceX is one of the major players doing that with their Starlink constellation in low Earth orbit. Another is Ball Aerospace. We worked with them to provide connectivity and analytics not only at the hyperscale cloud, but also on the edge. And then another partnership we have is not only thinking about the edge on the surface of the Earth, but the edge in space. And that's a partnership that we have with Hewlett-Packard, and they have a computer called the Spaceborne computer that was launched to the International Space Station that we've connected to Azure in the cloud and are now running exciting workloads on it.
Yeah, and that was really exciting to see the announcement around some of the things we're doing with genomics workloads and how we could be doing some of this compute in space and then sending the summaries down to Earth to do the rest of the computation on the ground.
So, Ranveer, that brings up the need for the research community to get involved and support this exciting area. So, can you tell us more what MSR is doing in this area?
Yeah, we are really excited about the partnership we are doing with you, Steve, and the rest of the community around this future vision of space that you laid out. We are looking at Microsoft Research, we are looking at what does the future satellite system look like? What is the future of things in space, things on the ground, and what kind of analytics could you run on it, both for Earth observation as well as space exploration. So, for example, one of the things we are looking at is what does edge compute look like in the future? How does a cloud-connected edge look like? If you take Azure Edge and run it in space, how would that look like? What would you run in space? What would you run in the ground? And what would you run in the data centers? The other thing we are looking at is the future of ground stations. One of the papers which we just published, this was in ACM SIGCOM, which is one of the top tier networking conferences, was on a new hybrid ground station architecture where existing ground stations cost a few $1,000,000, you set them up. But what if you could pair some of these expensive ground stations with inexpensive ground stations? Things that you see when you walk around, you see these dish antennas pointed up to the sky. What if you could have some of them be ground stations? You could put some ground stations which are inexpensive. They need not do uplink, but they could be receiving a lot of data, doing edge compute, and sending all of that data to the data centers. If you build such an architecture, it could significantly reduce the latency from the time an image is taken. You have a receiving ground station somewhere close by so that in near real time, you could start sending all of these observations down to ground. So this was one of the recent work we did on distributed ground stations, which is a hybrid, expanding the existing ground station architecture, which is right now, and doing the science, doing the research on thinking what could a future ground station architecture look like. In another piece of work, what we did was we're looking at artificial intelligence and looking at stretching the boundaries of what we can learn on space data. These satellites go around the Earth, they collect really rich imagery, high resolution imagery from some of our partners. But one of the key obstacles we run into is clouds. Whenever you see a cloud, well, the state of the art, what people do is you would filter out the cloud, you would identify where the cloud is and remove it so that you can run your AI algorithms on top of it. What happens then is, well, if, for example, for a farming application, there's an entire season which is cloudy when you're planting rice, for example, paddy in India. Well, that entire season is cloudy. With satellites, you can't see what's happening below the clouds. The system we built was called SpaceEye, where what we are doing is we are combining satellite data from different types of satellites, not just optical satellites, not just multispectral satellites, but radar satellites. These have synthetic aperture radar in them, and combining these to see through the clouds. So then what we can do is we can start predicting on a daily basis what is the system looking like under the clouds. We built a system called SpaceEye. We actually showed that with pretty good accuracy, over 90% accuracy in all 4 seasons, 95% accuracy in 3 of the 4 seasons. Snow is something we are still working on. But you can see how once we start bringing the latest advances in computer science, in networking, in artificial intelligence, in computer vision to space and work with experts like yourself, we can start lighting up so many new scenarios in the space industry. So we are continuing to stretch the boundaries around science and what is possible in space, working very closely with you and your team, Steve.
Ranveer, really exciting work, and as I heard you talking, it reminded me of the importance of the ground segment. And we often do talk about the spacecraft and the systems themselves, but ultimately it's the data getting down to the ground and being able to process and understand it. So one of the capabilities that we're building out, one of our core products, is called Azure Orbital. This is a ground station as a service where we're putting antennas at Microsoft data centers around the globe to be able to command and control satellites and be able to bring the data into the hyperscale cloud for artificial intelligence, machine learning, and to be able to draw the insights from it. Consistent with that approach I'd said in the beginning of taking a partnership approach, we're not only doing it with Microsoft antennas at Microsoft data centers, we've partnered with KSAT, Viasat, USEI, and others who have a network of antennas as well, hundreds in fact around the globe, that can also feed into the cloud. And this is important because it gives our customers the ability to scale their operations, have frequent downlinks with these different antennas around the globe, and ultimately save their resources on not having to build out these capital intensive projects around the globe, but focus on building out those space systems or analytics or leveraging the data from it, and ultimately paying for what they need and scaling for what they need on the ground infrastructure.
Yeah, this is such a powerful system, Steve. And one of the studies that you did in Europe around this, one of our deployments, was how we could significantly speed up some of these geospatial pipelines by doing AI at these ground stations. And that was super impressive. And it just shows that as we keep building on these technologies, we can envision a future of space that's going to be different, and it can enable some of these wow scenarios that we started this discussion with. So Steve, with that, what is that, if you think 10 years down the line, or 5 or 10, or however far you want to think, what is that development in space tech that most excites you, that gets you to work every day? What is that vision that you have around space?
Well, I would say ultimately it is that speed of technology that's changing, but it's really the democratization. What's happening now is that space, through companies like Microsoft and others, is being made more accessible to more industries, more people around the globe. So what does that ultimately mean? Why is space important for them? What we will be able to do with our partners is to connect the entire world, to connect the unconnected, to bring that data and connectivity to everyone anywhere on the planet. And then it's not only having that connectivity, but it's being able to learn about the Earth with these different sensors that are being put in space, but also learn about what's off the Earth and what's in the galaxies, the Moon, Mars, and beyond. So it's very exciting, tremendous change, and I'm proud to be part of it with the team here at Microsoft.
Yeah, this is so inspirational. This is something that the same for me, Steve, and exactly these points in particular around connectivity. When we think of that 40% of the world doesn't have internet access, and we need to push the technology barrier here, and we need to invent new technologies. And space is one of those key enablers. It might not be the complete solution, but it is a key enabler in helping us get there. And yeah, really excited. And this is not it. Maybe in the future, we could all be going to space with all the developments around space travel. Our next panel could be from space. So
I'd like that.
Yeah. So thank you again, everyone, for joining us for this panel on space, on this discussion with Steve. We are really excited about working with you, about partnering with you. Please do reach out. We do a lot of cutting edge research. We work with academics, we work with government agencies and R&D departments, and would love to work with you to envision this future of space as this technology is evolving at such a fast pace. Thank you again.
Thank you.